Hello and welcome back, everybody. We are moving on to the next portion of this discussion around legacy software to actually talk about architecture recovery. So we're going to talk about reconstructing architecture from code. So this means we don't necessarily have a diagram or even a description of what the architecture of this code base is supposed to be. And we're going to use the code base to figure it out. Now, even if there's no documentation at all, code still has structure. Even if it's crazy structure, it's still there and it's just buried in the implementation. Understanding the architecture can really influence how code changes ripple through the system. So it's really important that we can sort of start to recognize these patterns quickly, and it will hopefully help us navigate through the code base a little bit faster. We can recover the missing designs and understand the intent behind the design from the code base itself. We don't need to have a picture to do this. I'm not saying it's easy, but it can be done. We have the typical layered pattern, as we've seen before, where we have our UI, which can handle our user input and output and just do its display. You might have a controller of some kind, which is coordinating the requests. We have our service layer, which would contain all of our business logic, our logic layer, right? Maybe it's called service or business or logic layer. And then, of course, our data, persistence, repository layer, where we have our reading and writing and connecting to our data source. There could also, of course, be a models, domain models, object kind of package. So if we see some kind of architecture like that, it's easy enough for us to find the entry point. But hopefully we've already watched the previous video where we talk about debugging code, and we can sort of determine an entry point based off of our compilation and running of our code. This is going to really help us determine how the system first gets invoked, right? It's great to find our starting point so that we can trace our architecture and our flow, and it will allow us to very quickly map where things begin in the code. So there are some pretty common entry points. Hopefully within the language there is some sort of standardization that can sort of help us figure out where we might want to start. There's often a main or a main class if we're talking about a console or a desktop application. There are routes or controllers like a routes.typescript or something like that for web applications if we want to find a /login or a dashboard folder, those types of pieces. And there's also always UI action listeners, right? So buttons or menus or form submission. So even if we can't find the entry point, we can find one of these, set a breakpoint, and then use the skills we talked about in the previous video to go to definitions and find that flow of execution, work ourselves backwards. If we can, let's look for those layers. Let's look for method calls that follow some kind of system we might understand, right? Controller, service, and repository, there might be some kind of package structure that will allow us to sort of discern the layer boundaries. Even if the naming of these different packages gives us some kind of indication into the architectural design that may have been used. So we talked about the scratchpad method previously when we're talking about call graphs, and we're talking about different ways of determining what an architecture or what an execution flow, might look like. Now let's discuss this bucket approach. Now, even if we don't know the architecture at all, we can still group code into three broad areas. UI, meaning front end, handling, presentation, interaction. The logic, where we'll find business rules and workflows and calculations. And then our data, our persistence, our API calls, our file I/O, file storage, all of that. And we can draw connections. We can just use directional arrows. We can show that the UI flows to logic, logic flows to data. If we put something in UI that accidentally flows all the way to data, it gives us an opportunity to reassess what our buckets look like. And it allows us to note any of those weird reverse flows, like does the database do something by calling back into logic? Because it's possible that something weird is happening, right? We don't know necessarily. Now, once we've set that up based on what we can sort of see, again, we hopefully have already built and run the code, we can now validate that the bucket flow that we've just sort of sketched out is correct by code tracing. So let's pick a user task like logging in and going to a dashboard, or getting a full list of recipes from the database, whatever it might be, and let's follow it through the system. Set your breakpoints like we previously talked about. and ensure that we're actually going all the way through. Alternatively, you could set some temporary log methods at the entries and exits of each of our methods anytime that we want to sort of be able to follow that through. You can also set some temporary logs if we're going to make an external call to a database, to a third-party API, whatever it might be, so that we can note when those things are happening. And then we can compare that to our sketch. Does the data flow as we drew it, right? Are there any unexpected hops? Do we suddenly leave the logic package and end up in a helper package, in a legacy utility, right? Let's add to our drawing if we do. Do we have any missing components? Like, are there queues and schedulers or middleware that are also being interacted with that our sketch currently doesn't account for? If so, we can add to our diagram. And then we can really figure out what is it that we're trying to capture here. Well, we want to capture the entry and exit points for each of our layers. We want to make sure we understand where the seams of this product, of the code base are. We also want to make sure we understand the data shape, right? Do we have IDs? Do we have transfer objects? What are the payload sizes? And then we can also get a good feel for the timing. We can figure out where the bottlenecks are, the slower steps might be. We can also find where the errors and warnings might be based on what surfaces in our logs. We can also determine our outcomes, right? We can confirm that the paths that we marked in our diagram match what's actually happening. We can also now update arrows or components to reflect what's actually happening, because now we've taken our diagram and done this validation. And then lastly, we can now mark down the unknowns. What don't we know? What questions arose from running through this execution path? And let's go and investigate them. Now, there are some pretty common architectures that are a little crazy. So we're going to talk about them so that when you go out and try to look at legacy code, you might have some buzzwords or places to start your investigation. And the first is the monolith, right? One deployable with everything inside of it. This is going to be a huge code base with a big shared database, and our utility modules are just cross-cutting everywhere. And often we see that this happens because it grows fast and nobody took time to deal with the technical debt. They never split it. Any changes have crazy ripple effects because they're all so intertwined with each other, right? We have really slow builds and deploys because we're not able to separate out our pieces and sort of only rebuild the pieces that need to be rebuilt based on changes, because all of it is one big giant blob. What are we going to do? Well, we need to still find a way to identify seams. And right now those seams might be method seams. There might be class seams as well and package seams, but the seam level could sort of depending on just how monolithic the code base is. And we can add tests at those module boundaries and start to extract one feature at a time, sort of organizing this base hopefully a little bit more. Here is a picture here of a monolithic architecture. Honestly, a lot of what we do is monolithic, but we try to do our best to keep it organized monolithic. And once, right, yes, we've been working with a monolithic N-tier architecture. And what else we might be able to do is take something like this and then separate it out into a different type of architecture. So this actually shows just two different options here. Monolithic with what we're talking about, and maybe a more modern architecture might look something like this, more microservice-y. All right, what else can we see in the wild? We're going to see God classes, and there's a good chance we see God classes even in our own projects. Honestly, I've shown architecture diagrams that depict God classes in previous videos. So it's a class that knows and does too much, right? They're just huge classes with, when you try to ask yourself what's its responsibility, it's a bullet point list, right? Like we just have to keep saying, oh, and it does this, and it does this, and it does this. And it happens sometimes just because of convenience, right? We're trying to get stuff done quickly. Oh, we'll just add it right here. We don't take time to stop and think about where it should go. And sometimes it's more like, deadline, time crunch, let's just get it in, we're going to deal with it later, and we never really do. And this creates high-risk code, right? It's very fragile. If we change something in the God class, who knows what it might affect, because the ripple effect is just huge. There's so many different places that the code can go from here. So how are we going to work with something like this? The best way to do it is small changes. Don't try to be a hero, right? We said that previously. Method by method. Extract cohesive, useful helpers. Introduce interfaces around any hotspots that exist. Start to peel pieces off one by one, and make sure that we're always making sure things run before and after we've made changes. The next one here is an accidental MVC, and this is when we have this idea of wanting to do MVC, but the responsibilities start to bleed across layers. This honestly happens a lot in 3350 projects too, because we start to trend toward using MVC, but we don't really understand how to refactor our code appropriately to reach true MVC. So we end up with controllers that have business logic in it instead of in the service layer, or a view that's sort of reaching into the database, or even just reaching into the service layer instead of going through the controller, right? We have services that basically just act as pass-throughs because we didn't put the service business logic in the right place. This happens because we don't really understand how MVC works, or we haven't really taken time to define clear boundaries. It can also just happen from deadline pressure. We get the general structure in and we worry about fixing it up later, right? And we know that this makes it hard to test. We can have those ripple effects, unpredictable side effects. Our architecture is the backbone of our project. So what are we going to do when we see something like this? We want to make sure we push our logic, wherever it is in that MVC, into our services. Keep our controllers thin. Their jobs are really just to control our project without actually doing any of the heavy lifting of the project. We also really want to make sure that we are enforcing those data transfer objects between the different layers, between our seams. We don't want to pass long streams of parameter lists. So there are a lot of different versions of this model view controller architecture these days. And I'm not saying one is better than the other. I am saying plan and design with intention. Document what you're wanting so that when other people come in and contribute to the project, they understand what the intention was and where things should go. We need to plan and design those boundaries as best as possible. So I want you to take a second now and draw your app's current architecture without looking at the diagram that you previously created. So go into your project, do not go to your diagram, just use your code base to draw an architecture diagram. And once you're done, go ahead and look at that old diagram and see how close are you to what it looks like. Should we have actually maybe updated our diagram? Is it maybe a little bit out of date? Do we need more documentation and context in our diagram so that the decisions we've made are more obvious and are more like contextualized, right? They're more clearly defined and explained. There's lots of things that we can do, and having that architecture or diagram done well is so important. If you want to do something really fun, go into another group's project and try to draw their architecture, and you'll be surprised at how well or not so well they may have defined it. I have another activity here where you could actually go over to the Python repos on GitHub. Even if you don't know Python, we don't need to know Python to do this activity. And just draw one of the project's architectures based on what you've learned in the last few videos. So some of these Python libraries have existed for a very, very, very long time, and some are maybe more recent and more up-to-date and modern and will look like something that you're more comfortable with. But a really good way to get good at tracing code and understanding diagrams is to draw them and is to walk through code. So there's a great project where they've got sort of a lot of different packages and libraries that you can look at individually and get some good practice with this. Okay, so with that, we're all done talking about basically the maintenance and upkeep of a legacy project. Our final video is going to talk about adding to a legacy project. How are we going to actually add something to a legacy or existing code base that maybe hasn't been maintained that well or doesn't have all these documents and all the context ready for us. Okay, thanks everyone for watching, and I'll see you in the next video. Bye.